Show you where I'm at with this project. I've got declination mounted onto RA. The USB cable is just in there as a test as I'm going to bring it down. I've got it run up through RA and down, or up through RA and then up through declination. So I'll be able to run all my cabling up through the system. You'll see the cabling in there inside that tube where I've made an access hole. I'm just starting an alignment process just to kind of play with it. Things are going very well. Let's see, we'll go ahead and line on that. Do another slew here. I don't know where I'm at. Right now my switches are just glued on, but you can see the cam that the switch is positioned off of. This is on step X or 10, and I've noticed the ramp up. This is on the default ramp up. Usually on a lot of the telescopes I do, I put 10 degrees to do the ramp up. I left this at 5, and this has got a different must be a different I guess settings to slowly bring the mount into, to accelerate each axis, I guess you would say. Can sound like a jet engine take it off the way it slowly builds up. So it's actually turning out rather well. Oh, I think I just heard a limit switch click. The majestic head is actually doing very, very well. You can see what I did on my CG5 tripod is I welded together a stem that fits in there and threads in there. The assembly is quite sturdy. Do I continue to trust it once I put a telescope up here? I'm not sure. As you know, now that this weight has gotten up to, I need to weigh it now with both declination and RA on here, but I'm estimating I'm going to be at 30 pounds in mount alone on top of this tripod. One, is this tripod strong enough? I mean, this is cast, I think it's aluminum, and there really is no other, you know, it's just the weight pinching on this. So I'm not sure. I will probably, depending on what I decide to go to, I might make a wedge, which is probably the direction I'll go. I want to see how this majestic head does. I mean, it's pretty darn solid. I don't have too many concerns right now, but as I continue to add weight, you know, I don't have my balance bar on here. I don't have a counterweight. So right now this is just what you see is what you know what I'm working with right now. Using the Wemos CNC, just temporarily strapped to it. The electronics will go in the back. I'll have a 3D printed compartment back here for the electronics. The electronics will include a Raspberry Pi computer with Indy and the on-step computer. We'll go ahead and slew to another star here. I don't know if you can hear the stepper spin up. but it can be kind of dramatic sounding. It's pretty neat. It's definitely different. The speed up process, the process to change or put the axis in motion has changed. So this is where we're at right now. I think this is going to go back to the home position and flip meridian. I have a feeling the way it's looking right now. I have it to where it pauses at home and then flips meridian. I do not know if I mentioned this. I was looking at using slip rings inside of here. Slip rings are essentially give you the ability to rotate wires multiple times around an axis. And as long as I'm careful, I don't think slip rings are going to be necessary. And the slip rings I was looking at, you know, I would want USB 3 for my cameras. So that's like 9 wires, and the shielding is quite complicated, it seems like. I would need 4 wires for my, well, actually no, I don't need 4 wires for declinations, because the 4 wires for declinations will well, I will need one, I guess, down here. 4 wires for declination, and then 2 wires, possibly 4 wires for home and declination and limits. So when you start adding up all those wires plus USB 3, that's going to work without interference, you're talking a slip ring that's going to be probably more than $200. And at this point, I don't think it's worth it. I think just having USB 3 cable going in, have limit switches so that this cable doesn't get twisted up like a pretzel as it's rotating, and being mindful is all we're going to need. So this is where we're at. Still need to work on this mount. I want to redo it, but right now it's fine for my testing. And I do have new designs inside of Fusion 360 that I'll share, probably with this video or maybe another time. But so far things are progressing quite well. I'm very, very happy with the gearing, the motor. There was a lot of concern, it seemed like, with backlash with these particular gearboxes. You know, I'm not sure what to do other than point it at a star and see if PhD will be able to cancel out that built-in backlash that's in this transmission. There's a planetary 100-to-1 transmission on this stepper motor that, according to the specs, has a lot of backlash. I guess that's you can see some backlash there. Is that enough that PhD won't be able to compensate for it? I mean, there it's under tension, there it's under tension. I don't know. We will find out. I guess that's part of this learning process. There is a different gearbox they have called the Precision Gearbox, or whatever they label it. It has less backlash. This is the economy gearbox. So there's an update. Things are coming together pretty well. And I will show you my new designs that probably will be going to a wedge instead of this majestic head. One, this majestic head does not lock. It just is relying on gear meshing weight to keep it from moving. Essentially, it's a worm with a half moon gear, and that's how that particular gearing works. So this majestic head probably will go for this particular mount. So far so good. More testing and we'll see how it goes. Thanks for watching. Okay, this is the latest design that I have going in Fusion 360. You can see some big changes. Everything in red is metal. The majority is steel at this point. The Adm Saddle is machined aluminum. As I go through this, and maybe as I start to learn to weld better in different materials, there may be some materials that I will swap out steel for aluminum. We will see. That'll be part of the process also. You can see one of the biggest changes is this is kind of based on a wedge. I have not figured out the adjustment mechanism, or if there will be, whether it's a threaded rod or two threaded rods, how the threaded rods attach, how they swivel, how they, this would be hinged back here with steel hinges, that these two plates would then be able to change angle. So it's kind of a wedge. Since we have this larger surface area, I went ahead and broke it down to where RA would be supported with two sets of steel. The 3D printed parts would then sit in between them. Right now in this design, what's inside the 3D printed parts is just the threaded rod. So between the car bearing bottom here, threaded rod with a nut on this side, and then 3D printed parts in between. There is a chance that I found a supply of aluminum pipe that I may have aluminum to reduce weight in between these steel brackets, so that not all the pressure is on the 3D printed parts. It's something I'm going to think about, and as I design, that may be used. One place I do want to use this whole aluminum idea is, I'll show you here. Let's see, let's turn off deck. Oops, wrong button. So deck, let's turn off that steel plate. You'll see this green cylinders, that's representing this aluminum pipe that I'm talking about. Let's turn off our cam switches, top cam, bottom cam. We'll turn off the gear. So what that would do is, the red is the bearing, car bearing. That would mean between the car bearing would be this aluminum spacer or tube that would be bolted. So it would be metal, threaded rod, metal, metal. There will be, no plastic that will be under load. It will just be this threaded onto 3D rod, the metal plate that deck is welded to, the aluminum spacer that the rod is going through, onto the bearing, which is then steel. So you can see this is the threaded rod, and this would be the aluminum spacers that would then go in between there. So I would be printing these cams with larger holes to let those aluminum spacers come through the 3D printed parts. This is a hole or an area. It's just a representation right now of where the internal cabling will pass through that plate. Let's go ahead and turn declination back on. So inside here would be the pass-through for the USB cables and power cables up to declination. The cables would pass through, go in here, and this is where 4 USB 3 ports would be. It's a powered USB hub, USB 3 hub. That will be inserted in here. This particular USB hub does have on and off buttons which will protrude down through the bottom of this, so I can turn each port on or off if I choose. And then these will be 12 volt outputs for cameras, anything else up on declination that needs 12 volt power. I will have a buck converter in here to bring the 12 volt power down to 5 volts to power the USB hub, and if I need 5 volts anywhere else up in here, it will be available. So 5 volts, 12 volts is what's going to be available up in this area. This will rotate with this is a representation of an Adm Saddle that I just mocked up real quick. It's not accurate. I have on order the dual saddle, so it has the Vixen and the is it Losmandy? I can't remember the other saddle name, the wider one. The Vixen is the smaller one. The larger saddle is it'll come to me eventually, but it's the dual saddle that will take either mounting type. I don't have it attached yet, you know, as far as in this model, because I haven't got that part yet to look at it. I will show, let's see, let's turn the saddle off. The design up here on deck. Let's go ahead, this is the electronic section. You'll see I have these aluminum spacers also in here. What's unique about this is, if I remember right, I showed a video where I had the lug nuts, and they were through-holed, the lug nuts. They were not, so it's a 29 millimeter long threaded bolt that's this long. So the plan is, let's go ahead and let's open up deck here. Let's turn off the gear, the cam. We'll turn off the gear. So this is wheel bearing. This is aluminum spacer. This is the through-holed lug nuts. This is the steel plate. And so what we will use is bolts to go down through the steel plate into the lug nuts. There's the threaded rod that is running through declination to this side of this mounting point. So again, it's going to be metal on metal on metal on metal on metal, and then I need to make a decision if this area here where it goes threaded rod, and those are lug nut, by the way, I'm sorry, I think I called that threaded rod, but that's lug nut off of the wheel bearing. This is the threaded rod that comes down through. I will have to make a decision if I take this aluminum concept and bring it down so it'll be metal on aluminum, metal sleeve on metal. No, right now the 3D printed part is what's inside of that compression. So I probably will. The aluminum, the amount of weight that I'm adding will add a lot more reliability, I suppose, than putting this pressure on the 3D printed part. So I probably will do the aluminum spacers in here so that when this assembly is tightened together on this threaded rod, we're not just squeezing 3D printed material here, but we'll be squeezing or tightening against an aluminum pipe that will be around this threaded rod. So that's kind of the major updates right now. Oh, I did rotate RA. You'll see my motor is now coming off to the side. Reason is, if I had the motor down here, it kind of gets in the way of this wedge assembly. The motor, it is possible fit. The motor would, if I were to rotate this around, the motor would be inside the wedge, and there is enough clearance to actually do it. The question is it smart? Am I going to back myself into a corner? Is it going to cause problems? So why not just go ahead and throw the motor? I rotated the entire assembly, brought the motor over here. Right now, home and limit switches are over here. That may change also. And as I start to continue working on this and all of these things around here, my 3D printed parts are probably going to start turning into more of a facade, more of let's make this giant hunk of steel and aluminum pretty. They will be covers. So I'll be designing and redesigning. I'll be covering up a lot of the steel with 3D printed parts. Case in point, this is where I currently plan on putting the electronics. It's down here in this base. Let me turn some of this stuff on. Deck. Right now I just have a ugly box that will, as a representation of a 3D printed section here where the mount electronics will go. So the on-step computer will be inside of here. The Raspberry Pi computer will be inside of here. The power ports will be on the back of here. I'll bring 12 volt DC in, possibly an Ethernet cable with PoE. I'll have a port to bring into here. If I want to think about using PoE to power the Raspberry Pi, there are PoE hats you can put on a Raspberry Pi so that you can power your Raspberry Pi with PoE Ethernet cable. Power over Ethernet is what that stands for. I'll probably have a Wi-Fi antenna sticking off of here. The on-step computer will be Wi-Fi, but how I link the on-step computer to the Raspberry Pi inside this box, there's a few ways you can do that. You could go both of the devices via Wi-Fi, where they would both, they could connect to each other internally with Wi-Fi. We could do USB cable from the on-step computer to the Raspberry Pi and connect via serial. We could do Bluetooth. I've done Bluetooth, where the Raspberry Pi connects to the on-step computer with Bluetooth. And so the Raspberry Pi with the Indie server can talk to the on-step computer inside of here multiple different ways. So it's just a matter of figuring out the most efficient way and what makes the most sense. The less cables I have coming up my tripod or whatever it is into this box, the better. One of the goals is to keep all the camera, the photography gear, the telescopes, the focuser, the filter wheel, all the cabling will stay up on deck and not droop down like most mounts. That's the whole concept, or the what I'm hoping to do by running the USB 3 cable up through RA, up into deck, and into this breakout or electronics box up here on deck. This electronic box does rotate with the deck head, so all the cables going to devices up on deck will rotate with these ports. So much less chance of cable entanglement. So that's where I'm at right now. I think it's progressing quite well. My weight does continue to go up. I'm estimating, and I need to do a final weight check, but I'm thinking this is going to hit 30 pounds. That's without counterbalance. Counterbalance is another thing I'm going to look at. How much do I need? It's going to be an experiment. The stepper motors and the belts are pretty strong in that, you know, yes, they'd be much more efficient if this was balanced. So I think balancing is still absolutely going to be necessary. I'm not going to even kind of start thinking that way. I'm just going to keep balancing as a primary objective or feature that I'm going to have. I know some mounts you've seen where the balance points are such a way that they don't have balancing weight. So that's another topic that I just need to keep thinking of. But that's where I'm at right now. So thanks for watching, and we'll talk to you later.